Now that we've looked at eBGP, let's examine iBGP a little more closely. We want to do the same type of thing we did with eBGP, get a working definition of iBGP, understand some of the unique characteristics of iBGP peers, and then configuration of iBGP. Now, iBGP, or an internal BGP, is the relationships between peers within the same autonomous systems. In each one of the circles in the diagram, the routers in the top are internal BGP peers. They have direct relationships. Well, they don't even need to be direct relationships, but they're within the same autonomous system. Again, AS numbers between 1 and 65535. There are internal private AS numbers. But one of the things that's very different about iBGP is the peering does not require directly connected interfaces. There is no need for a multi-hop command in iBGP. If you think about it, BGP can be used on one end, let's say Chicago. Let's say that's where the internet ingress point is for a service provider. And let's say there's another one in Raleigh, North Carolina. They can be iBGP peers. There can be a lot of routers in between and a whole service provider network using OSPF, for example, but they'll still iBGP peers. They're not directly connected, but they have knowledge of what's going on the outside of the network by way of BGP peering. So they don't need to be directly connected. iBGP peers can be particularly finicky because they have a lot of more requirements than external BGP. And again, this all just comes back to loop prevention. Next hop addresses are not changed when advertising to iBGP peers. So if it was learned by another router outside the autonomous system, it gets to an iBGP router and it's passed on, it's going to point to the next hop address of the external router. Keep that in mind. If the routes aren't known in the IP routing table, iBGP is not going to advertise them, sometimes called synchronization. You'll notice that in each one of these circles, there are direct connections between each router because iBGP routers have to have direct peering. They have to be in a full mesh. If there are 2 iBGP routers, 1 connection. If there are 3 iBGP routers, obviously more connections. If there are 27, they all have to be directly connected unless you're using route reflectors and confederations. And this is a requirement. If iBGP routers are not fully meshed, they will not pass on learned routers to other iBGP neighbors. Another thing, I mentioned this just a moment ago, that synchronization is required as far as IGPs are concerned. If you don't want to have to deal with synchronization issues, you just put no synchronization in the command when you're doing that. But it can be extremely difficult to figure out missing routes if you haven't thought that through. The configuration of iBGP peers is actually very similar to eBGP peers. It's neighbor, the address of that particular peer, remote AS. The difference in this particular case, it's going to be the local autonomous system number. So if it's router BGP 65001, the neighbor address remote AS is going to be 65001. You don't need a multi-hop statement. If you want to specify the source for updates, you can use the neighbor address update source interface command as well. For instance, if you wanted to use a loopback interface.